Okay, by the end of this video, what we're hoping that you know is what the discriminant of a quadratic expression is and what do we need to use it for. So let's get into talking about the first part, which is what is the discriminant. Okay, so the discriminant is the part of the quadratic formula that's underneath the radical symbol. So b squared minus 4ac, you've heard a lot about this. It's a part of the quadratic formula. We're going to focus on just what's under the radical. So notice that I'm not including the radical in this example, or in this definition. It's just b squared minus 4ac, the value of the number under the radical. So here's what the discriminant tells me. It actually tells me a whole lot about this equation. Okay, so if the b squared minus 4ac, if the discriminant is a positive number, you know that the quadratic, when we solve it, is going to have two real number solutions. We can say it's exactly two numbers. Okay, if b squared minus 4ac is exactly 0, if we simplify it and it comes out to be 0, we know that when we solve the quadratic, it's going to have exactly one real number solution. So that rare case where we only end up with one answer, that's always going to happen when b squared minus 4ac is 0. Okay? If b squared minus 4ac is a negative number, which means if we have a negative number underneath the radical, that means that you are going to get two complex number solutions, which means you're going to get two answers that have I in them. Right? So we can classify what types of solutions you should expect to get before you ever solve the equation just by looking at b squared minus 4ac. That's the first thing it tells us. The second thing it tells us is that if we wanted to factor this expression, can we? Right? Because a lot of times we'll look at a quadratic equation and we'll try to factor it, or we're not sure if we can factor it, and we kind of got to go through and try, and maybe sometimes we fail. So instead of going through that whole process, we can look at the discriminant, plug into b squared minus 4ac. If the value of the discriminant is a perfect square, then we know we're going to be able to factor the expression. If it's not, then we know that we can't factor the expression and we don't even have to try. So as an example, if underneath the radical, if I plugged in b squared minus 4ac and it came out to be 81, we know 81 is a perfect square. We're going to be able to factor that expression. If it comes out to be like 17 or something that we can't square it in our heads, we are going to say it is not a factorable expression. We're not even going to try. So let's just take a look at some examples. Okay? So here's what I'm asking for each of these quadratics. I'm saying how many solutions does the quadratic have? And we're going to also classify what types of solutions. Right? And then once we know that, we're going to say, is this an expression that I could factor? So let's start off with this first one over here. Okay, so the first problem, okay, is asking us, okay, what types of solutions should I expect to get from x squared minus 4x plus 5? So let's just use b squared minus 4ac. So b squared minus 4ac, that's the discriminant. Okay? And I'm going to plug in. Well, my b is negative 4, so it's negative 4 squared minus 4 times 1 times 5. So let's see what this comes out to be. This is 16 minus 20, which is negative 4. Okay? So if we go back and take a look at what we just said, we said if b squared minus 4ac is negative, the quadratic has two complex number solutions. So that's the conclusion that I'm going to draw. I'm going to say how many solutions? There are two solutions. Okay? Two solutions. Okay? And those solutions are complex numbers. Right? So we're going to say two solutions, complex solutions. That's what comes out of this. Okay? That's all we have to answer. Is this factorable? In this case, we're going to say negative 4 is not something I could square root. Okay, it is not a perfect square, so I'm going to say not factorable. Okay, so we're done. Okay, let's look at the second one. We're going to just do a couple more examples of this. The second one is saying, can I factor this expression? How many solutions are there? What types of solutions? So I'm going to do the same thing. B squared minus 4ac. Well, this looks like negative 5 squared minus 4 times 3 times negative 2. Well, this is 25, and this comes out to be negative 12. Negative 12 times negative 2 is positive 24. Okay, so it looks like my discriminant is 49. Right? So I'm going to use this. Let's go back to our reference. Our reference says if b squared minus 4ac is a positive number, you have two real number solutions. Okay? It also says if the discriminant is a perfect square, then the expression is factorable. So I can use those two facts and say, right, if we go back to our problem, that because this is a positive number, I'm going to say that there are two solutions. Okay? I should expect to get real solutions, which means no I. Okay? And I should expect that I can factor this expression. This is a factorable expression, which means you can do AC factoring and turn this into two parentheses, two binomial expressions. And I get all of that just by doing a quick check on my calculator, or a quick check by plugging into b squared minus 4ac. Okay, one more problem, okay, about using using the discriminant to find out some information about quadratics. Right. So in this case, we have to watch out for something. B squared minus 4ac is a part of the quadratic formula. And the quadratic formula stipulates that it must be set equal to 0 before you can use it. So in this case, I'm going to say, let's do that first. It can't be equal to 20. So I'm going to say, first, let's make it usable in the quadratic formula. Okay, by subtracting 20 on both sides. When I subtract a 20 here, I'm going to say I get 32. Okay, so if I go to my b squared minus 4ac now, my discriminant, right, I'm going to plug in what I know, and this is going to be 16 squared minus 4 times 2 times 32. Okay, so here's the thing. I can go to my calculator. Let's find out what it is. And this is a slightly bigger number, so we'll get some help. All right, so this is going to be 16 squared, okay, minus 4 times 2 times 32. Let's find out what the answer is. It looks like 0. Right? I plugged into the discriminant, and I got 0. Okay, so again, let's take a look at what that means. This says, if b squared minus 4ac is 0, the quadratic will have exactly one real number solution. So let's state that. Okay, so we're going to say there is one solution. Okay, that solution is a real number. Okay, and here's what I can say. This is a factorable expression. Okay, here's how I know. Right? Again, what this told us back on the last slide was that if the discriminant is a perfect square, then the expression is factorable. 0 is a perfect square. 0 is 0 squared. So 0 is going to be a perfect square. We're going to say, yes, this is factorable, right? So don't just look at numbers like 49 and 16 and 81. 0 is also a perfect square, which means we're going to say anytime the discriminant is 0, that means that we have a factorable expression.